When we want to quantize measurements such as mass, length, speed, temperature, and time, all we need is a number, known as a magnitude. However, for measurements such as displacement, velocity, and force, we need a direction and a magnitude. Vectors have direction and magnitude, while scalars just has magnitude. Vectors have an initial point and a final point. So let's say that vector starts at A and it will end at B. So we can call this vector AB, since we're starting with A and we're ending with B, and we draw an arrow on the top to indicate that this is a vector. Now there are different ways we can describe a vector. Let's say we have a vector that goes to the right 3 units and up by 2 units. So one way we can describe this is by using angle brackets. This is known as the component form. Since we're going 3 to the right and 2 up, we can do 3, 2 in the angle brackets. We can also write this in vector notation. This would be 3i plus 2j. I represents the x part and j represents the y part. And in 3 dimensions, k would represent the z part. So let's say we have point A at 0, 1, 1 and point B at 2, 2, 0. And V is vector AB, starting from A going to B. So how would we represent this on a 3-dimensional graph? So for part A, we're going 1 unit to the right for Y and 1 unit up for Z. And then A is not displaced in the x direction, so point A would be there. Point B is 2 units in the positive x direction and 2 units in the positive y direction. So point B would be about there. And then for the vector, we start from A and we go to B. And then vector V could be found by subtracting point B by point A. So we start with the x component of V, which is 2, and we subtract that by the x component of A, which is 0. So you have 2 minus 0. And then we do the same thing for the y components, 2 minus 1, and the z component, 0 minus 1. So vector V would be 2, 1, and negative 1. If we wanted to write this in the vector notation, it would be 2i plus 1j minus 1k. If we wanted to find the magnitude or distance, we would imply the distance formula essentially. So the magnitude of vector is absolute value bars around the variable. So this equals to the square root of the x component squared plus the y component squared plus z component squared. So the magnitude of this vector would be the square root of 2 squared plus 1 squared plus negative 1 squared, which is radical 6. Now, let's talk about vector operations. You can add vectors onto each other. So, graphically representing the addition, if we have vector A and vector B, we can start by putting the tail of vector A at the origin. And then since vector A is 2, 1, we go 2 to the right and 1 up. So vector A is right here. Vector B is negative 1, 1. So we can start by putting the tail of vector B on the head of vector A, and then we go 1 to the left and 1 up. We can call the resultant vector vector R, and R is equal to vector A plus vector B. Now an important thing to note is that vector addition is also commutative, so it doesn't matter if you start with vector B or vector A. So now we're going to start with vector B. We go 1 left and 1 up, and now we're going to add vector A from where vector V was. So from vector B, right here, we're going 2 right and 1 up. And as you can notice, we end up in the same place and we get the same resultant vector. Another vector operation is scalar multiplication. So if we have a number outside of a vector as such, so let's say that k is a number, k gets multiplied into or scales the vector ax, ay by simply distributing k into the x component and the y component. So for example, if our scalar is 2 and we have a vector of 3, -1, the result of this operation would be 6, -2. If you have a negative k value, the direction of the vector will be reversed. Alright, so let's do some examples with vector operations. And I'll demonstrate this graphically and mathematically. So we're going to start with the graphing part first. So let's say we have vectors a, b, and c. So vector a is -2, 0, vector b is 0, -1, and vector c is 1, 2. So the first question asks what 2a plus c is. So vector a goes 2 units to the left. So since we're scaling it by 2, we would actually go 4 units to the left now. So we'll start out from the origin, and we'll start with vector a, or this is vector 2a. Next we can add vector c, starting from the head of vector 2a, and vector c is 1, 2. So from here we go 1 to the right and 2 up, and we can say our resultant vector is 2a plus c. Alright, so mathematically we have 2 scaling vector a, which is -2, 0, plus vector c, which is 1, 2. So doing the scaling operation first, we would have 2a be equal to -4, 0. We're adding this to 1, 2. So 2a plus c equals -3, 2. Up next we have a minus 2b minus c. So b goes down by 1 unit, so 2b would go down by 2 units. So it doesn't matter which variable you start with, so let's just start with a again. So a would be 2 units to the left, and then this is actually, we're adding a -2b, or we can say we're subtracting 2b. But this means instead of going down by 2 units, since we have the minus sign, we're going to go up 2 units for the -2b. And then c is 1, 2, but since we have another minus sign, we can treat it as a scaling factor of -1. So instead of going 1 to the right and 2 up, we're going 1 to the left and 2 down. And then our resultant vector would be from the origin to where our last vector ends, and this one would be a minus 2b minus c. I will also demonstrate mathematically. So a would be -2, 0, minus 2, scaling b, which is 0, -1, and minus 1, 1, 2. So we can distribute the scalar into the vectors first. So -2, 0 would stay the same, and then -2b would be 0, 2, and then distributing the -1 in would have -1, -2. And the final answer of a minus 2b minus c, this equals -3, 0. Okay, so a unit vector is a vector with a magnitude of 1 unit, and we can find the unit vector by this following equation. U equals a over the magnitude of a, in which a is a vector, and then the denominator we have the magnitude, and then u is the unit vector. So let's say we wanted to find the unit vector of a equals 2, negative 3, 1. We'd need to start with the magnitude. Again, we're going to use the magnitude equation, which is the square root of the sum of each component squared. So here we'd have 2 squared plus negative 3 squared plus 1 squared. This equals radical 14. By implementing the equation, we would have 2, negative 3, 1 divided by square root of 14. Now this could be usually rewritten as 1 over radical 14 as the scalar right in front of the vector. And then if we distribute 1 over radical 14 inside of the vector, we'll get 2 over rad 14, comma, negative 3 over rad 14, and 1 over rad 14. So recall that vectors have a magnitude and a direction. So we found that the magnitude of this is radical 14. The direction would be the unit vector.